Recording in progress.
Hey guys, Mr. Riz here to help you out with the 1.3 video notes in Algebra 2. Here we're going to be looking at Extrema and End Behavior. So we'll do a little warm up here. See if you guys remember stuff from 1.2 here. Go ahead and read this question here. Assume that P is a relationship that contains the points 3 and -4. What other points must be included if the relation is, all right, even, odd, symmetric about the x-axis, or symmetric about the y-axis? Pause the video, see if you can try it on your own. Let's check our answers. All right, so if it is even, we're going to be able to reflect it over the y-axis. So we can just switch the x number here, and we'd have a point at -3, -4. Or if it's odd, it's going to be in the opposite corner. So if it's at 3, -4, it's going to be over here up at -3, +4. Or if it's reflected over the x-axis, we flip it over to the bottom. So if it is at 3, -4, it's going to be flipped up to 3, +4. Symmetric around the y-axis, that's what it means to be even. So it's going to be the exact same point. All right, here are our math standards that we're going to cover. Here's our goals here. So first thing we're going to do is make sure we can identify extrema of function. There's a couple different types. We're going to make sure we can look at them on a graph or not so much as an equation, typically on a graph, what they are, and then identify end behavior. So what happens at the start and the end of a graph? Okay, so here's some definitions for you. The graphs of functions can have high or low points where they reach a maximum or minimum value. The maximum and minimum values of a function are called extrema. The maximum is at the highest point of the graph of a function, and the minimum is the lowest point of the graph of the function. Now, a relative maximum is located at a point on a graph where the function has no other nearby points have a greater y coordinate. And a relative minimum is located on the point where the function has no other point. So relative means like just a certain part of the graph. There's like the top of a hill or the bottom of a valley, but it's not like the lowest point on the graph. So if you have something that goes up and has a little bit of a dip, that little bit of a dip is a relative minimum. Now, absolute, sometimes we call these absolute maximums and absolute minimums because they are the absolute highest and lowest point on the graph. We'll go through some examples to make sure you know the difference. All right, here what we're going to do is we're going to try to identify the extrema and estimate the x and y values. Okay, so if we look at these functions, go ahead, let's try to pause, just jump right into this and see if you got this. So in this first equation here, we have this little dip. So this function is a decreasing function, okay? So at the start, this decreases as it approaches 0 from the left, and then it increases from the right. You'll do this a lot in calculus if you ever take this, try to figure out the values algebraically where it's increasing or decreasing. So right here is probably the lowest point on the graph is at 0, -5. So that 0, -5 is a minimum. It is a absolute minimum because it's nowhere on our graph does it get any lower than that. We do not have any absolute maximums because there's no point distinctly the highest value. All right, so if we look at this next g of x, here we go. Now, this function g of x is increasing as it approaches -2 from the left, and then it decreases as it moves away from -2. Okay, so this -2, 8 is not the highest point on the graph, but it is still a higher point. Notice here over here, this point is higher than right there. So that point is a relative maximum. You might look over here. Let's continue. After that, as it approaches 0, it decreases, and then it increases. So it goes down, then up, makes a hill at 0. But there are not any fewer points. So right there, there are no lesser y coordinates around the surrounding area of 0, 4. So, however, 0, 4 is not the lowest point on the graph. There's definitely points over here that are low. So this is a relative. So if we kind of go back and look at the difference, especially graphically. All right, this one is a minimum, okay? This one here is a relative minimum. Our graph does not get any lower than that. So it is minimum, straight up, that is the minimum. This point is the relative minimum. Like if we would zoom in and only look at this spot here, all right, that would be the lowest point if we zoom in. So it's relative, but it's not the lowest. All right, let's get Okay, so let's try to think about it outside the box. So why are extrema identified in a graph of g of x relative, maximum, and minimum instead of the absolute? Okay, because they are not the absolute highest points. If we went further points on the ends, we'd find points that have bigger or lower y values. Okay, so let's try to do that now using some like real world scenario here. So here we got this table and graph is to estimate the extrema of the function that relates to the number of hours since midnight, which is x here, and the number of posts being uploaded. Okay, so we're going to describe each extrema here in its situation here. So really we want to look at the graph a lot. Okay, so if we look at this graph here, if we think about the maximum right there. So the number of points sent 12 hours right here at 12 after midnight is the highest point or the greatest point that any other spot on the entire graph during the day. The highest point occurs when x equals 12. Therefore, there is a maximum number of points right here at about just over 11.5, we would say, or 11.5 100,000, so 1.15 million right there at noon. So that's what it means based off the story. Now, the minimum, do we have a absolute lowest point? Let's say it's right there on the graph. So after 4 hours, okay, after midnight is the lowest on the entire graph. And we kind of have this line here. We don't know exactly the end. So we're kind of looking relative to, of course, everything, but we're going to assume that this is the lowest. So the lowest point occurs when x equals 4. Therefore, we have a minimum number of points around 4 a.m. of about 180,000. Now, what about relative maximums? Do we have any of those? So if we look, we do have another peak, a little bump to our graph here, and that's sent around 16 hours after midnight. So this is greater than the surrounding points here, okay? So we have a relative peak around 16, when x equals 16. So there's a relative max around 1600 hours, which would be 4 o'clock p.m. of just over 1,000,000, so about 1.02 million posts. Now, relative minimum, is there a low dip in the graph? Not the lowest, but just a low dip somewhere. And I would say it's right there around 14 hours. All right, so that's the lowest point during that time. You can see that graph dips around when x equals 14. We would say that's a relative low during that time. And that's about 2 p.m., 1,400 hours, about just over 900,000 posts. Okay, this is a really good graph if you're struggling. What's the difference between minimum and relative minimum and maximum and relative maximum to kind of look at, see how they're different. All right, second thing we're going to be looking at here is end behavior. Now, end behavior is going to involve infinity, and we're going to be talking about negative infinity and positive infinity. Big thing to help you out, negative infinity is on the left, positive infinity is on the right. Here we go. So end behavior is the behavior of the graph as x approaches positive or negative infinity. As you move right along the graph, so starting from the left to the right, the x values are increasing towards infinity. This is denoted as x goes towards infinity. At the left end, we're going to be decreasing, going towards negative infinity. So that's going to be denoted as x approaches negative infinity. So when a function f of x increases without bounds, so if it just keeps going up, 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 we say f of x goes towards infinity. When a function goes down, 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 we say f of x approaches negative infinity. Okay, so we're going to look at these ones here, see how we write these. So we got the left side goes up, 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 up. The right side goes down, down, down. Now on this one, the left goes towards 2. The right side goes towards 2. Okay, so in this first one here, as x decreases, f of x increases. So we would say that f of x decreases, okay? As x increases, f of x decreases. We said that. Thus, as x approaches infinity, f of x approaches positive infinity. So as f of x goes towards negative infinity, all right, mixing these up. It's easier for me to write these things, say as x approaches negative infinity, f of x, the y value, goes up towards positive. Oh, this got cut off here. On the other part here, as f of x approaches positive, or x approaches positive infinity, f of x goes towards negative infinity. Now on B here, this is easier. As x approaches negative infinity, g of x goes towards 2. And as x approaches positive infinity, g of x also goes towards 2. So pretty much you're either going to have negative infinity, positive infinity, or a whole number as your answer. So look at these graphs, see if you guys can go ahead, write it out in the proper notation here of the end behavior. Pause the video, give it a try. All right, so here we go. We would say as x approaches negative infinity, f of x approaches negative infinity. It is going down when we are going to the left. Going to the left, we are going down. As x approaches positive infinity, we go to the right. Our f of x, or y, keeps going up, positive infinity. All right, try to write these f of x's, approaches, or end behaviors of these nonlinear functions. Go ahead, pause the video. Hopefully we can clear things up. Okay, for this positive infinity, as we move left or right, f of x ends up at the top, right? It increases. On the left, it increases. On the right, it increases. So as x approaches negative infinity, and even when x approaches positive infinity, f of x both goes towards infinity. So think of this. This saying is what happens on the left side. That saying is what happens on the right side. This is how we say it goes up forever. That's how we say it goes up forever. So both sides, they go up forever. Now on g of x here, what happens on the left side? G of x goes down. So it goes towards negative infinity. What happens on the right side? G of x goes up. All right, let's try to figure this out. Again, try this one on your own. I know it does get a little confusing with these symbols. Which one do I use? Hopefully, if you get this one right, it kind of clears them up. So pause the video, give it a shot. All right, as x goes to the left, we are going down to negative infinity. As x goes to the right, we are going down towards negative infinity. There we go. So both f of x's should be negative infinity. All right, if we look here at a graph, what's the end behavior in a story problem here? So this graph shows the altitude of a drone minutes after flying x minutes. All right, we're going to describe the end behavior of the situation. So one thing about this here, we don't have any time before leave, so there's nothing defined for x less than 0. So the end behavior as x approaches, there's no f approaches negative infinity. So that's it. The only thing we can say is as x approaches infinity, that looks like it's going to just keep going up, 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 up. So it's going to be at positive infinity. All right, try the same thing here. Just check with this story problem here. We got ride sharing here. We got x is the number of miles and y, or f of x, is the cost. Okay, so which one would this match here? Take a second, pause, see if you guys get the right answer. All right, this one should be D. So there's nothing defined when x is less than 0. It starts right there. But as x approaches infinity, f of x is going up all the way. All right, so what does that mean in our situation here? All right, so the further Mika travels, so as the miles increase, the more the ride costs, which makes sense. All right, here's the exit ticket, but remember with our exit tickets here, guys, you can check your answers on this video or on the notes, but you guys will be working on the CYUs. Thank you guys for watching. You guys have a great rest of your day, and be safe, be kind to each other.